What if, as you close your eyes tonight, the stars above you were not just distant fires but actors on a cosmic stage, waiting for their moment under the spotlight? Imagine the universe as a grand theater, its curtains woven from darkness, its lights shining as constellations, and somewhere, just off stage, a mysterious performer preparing to step into view. That performer is a traveler called 3I, divided by Atlas, and its arrival has already turned our familiar skies into something far stranger than we expected. Hey guys, tonight we are going to drift gently into this unfolding story, where asteroids glide like dancers, comets paint luminous trails across the heavens, and an interstellar visitor slips quietly into our neighborhood, carrying with it chemistry older than Earth itself. So, before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And, as always, I would love for you to share your location and local time in the comments. It's a way for all of us scattered across continents and oceans to feel connected under the same night sky. Now, if you're ready, let's begin. The story opens in the late summer of 2025. By then, astronomers had grown used to a steady rhythm of discoveries, tiny asteroids catalogued, comets traced on their expected arcs, satellites mapping every blink of light. Space seemed predictable, almost routine. But as September approached, something began to shift. Patterns that should have been ordinary turned strange. Movements that should have been solitary became crowded. It was as though the cosmic stage had grown restless, summoning not one performer, but many, each stepping forward in a tightly choreographed sequence. At first, the headlines were modest. A new asteroid, FA-22, had been logged and confirmed. It was large, mountain-sized, and passed Earth at a safe distance. Astronomers smiled, catalogued the numbers, and moved on. But within days, another object appeared, and then another, and then a comet brightened unexpectedly in the same patch of sky. What had seemed like random appearances now began to resemble a procession, one body after another, all gathering in the weeks leading up to October. People who never looked up from their busy routines started to notice the news, while those who already loved the night sky began to wonder what exactly was happening. And hovering behind it all, quietly but insistently, was the most mysterious visitor of all. 3I divided by Atlas, the third confirmed interstellar object in human history. Unlike the others, it was not born within our solar system. It came from elsewhere, perhaps from a star, older, colder, or stranger than our own. Its greenish glow and impossible chemistry marked it as different, and its timing made scientists pause. Why now? Why here? Why during the very weeks when our cosmic neighborhood was already alive with activity? Think of a stage curtain slowly parting. On one side, you see the familiar, Earth's orbit, the moon circling us, the distant pull of Jupiter keeping its great belt of asteroids in line. On the other side, you see the unexpected. New comets streaking in like brushstrokes across the twilight, asteroids crowding together in uncanny clusters, and beyond them, a faint but unmistakable traveler slipping in from the depths of interstellar space. This curtain is not fabric, but time itself. And in September 2025, time seemed to fold in such a way that everything ordinary and extraordinary aligned. It is tempting to treat such alignments as accidents. After all, the laws of gravity are impartial. Asteroids follow their paths because physics dictates it. Comets brighten because ice turns to vapor as they near the Sunday interstellar visitors appear because other star systems eject debris, flinging them across the galaxy where some eventually pass through ours. From one perspective, there is no mystery, only statistics playing out. But from another, more poetic perspective, we cannot help but wonder, is this coincidence or choreography? Consider how human beings have always interpreted the sky. To the Babylonians, a sudden star was an omen of kings rising or falling. To the Greeks, comets were fiery messengers from the gods. In ancient China, court astronomers would risk their lives to interpret celestial anomalies for the emperor. In each case, what was seen above was read as a mirror of what might unfold below. Even now, when we know the mechanics of orbits and chemical compositions, some small part of us feels the same shiver. The sky is not just scenery. It is a story unfolding, one in which we are also characters. So as September's parade began, the atmosphere was not one of fear, but of awe. News anchors spoke of close calls, but scientists reassured the public. None of these visitors posed a threat. Instead, they represented opportunities, moments to test our detection systems, to practice our planetary defense protocols, and to expand our understanding of how connected our solar system truly is to the galaxy beyond. For the amateur astronomer standing under a rural sky, or the child gazing upward from a city balcony, it was a reminder that the heavens are never silent, that even in an age of satellites and screens, there are still mysteries that arrive unannounced. And in that quiet moment, September of 2025, we found ourselves at the threshold of something larger. On the surface, it was a busy month in astronomy. Asteroids, comets, a visiting interstellar body. But beneath the facts lay a deeper suggestion that we are no longer passive observers of a distant, unchanging cosmos. We are beginning to sense the rhythm of a larger symphony, one that stretches beyond our planet, beyond our star, beyond even the thin spiral arm of our galaxy. We are starting to realize that our role is not just to watch, but to listen, to notice the patterns, however faint, and to let them remind us that we, too, are part of this grand choreography. As you let your breathing slow and your eyelids grow heavier, think of the universe in this way, a theater vast beyond comprehension, where every asteroid is a dancer, every comet a brushstroke, and every interstellar visitor a rare soloist carrying secrets from worlds we may never see. Tonight, we take our seats in the audience. The curtain is rising, and the first act, the story of an asteroid parade that turned into something much stranger, is about to begin. The first headline in that restless September did not scream of danger. Instead, it spoke with a quieter voice. An asteroid named 2025 FA22 was gliding past Earth. To the average reader, it was just another number, another stone among countless stones. But to astronomers, it was the beginning of something unusual. FA22 was no pebble. Imagine a mountain between 130 and 290 meters wide, torn from the body of creation itself. Now picture that mountain set free, drifting through the void, indifferent to the lives of billions below. On September 18th, 2025, this mountain sailed by at a distance of just over 2 lunar spans, roughly 835,000 kilometers. In cosmic terms, it was close enough to catch our breath, but far enough that our world remained unharmed. For the scientists who track such things, it was routine. Numbers on a screen, orbits plotted, risks assessed. But for the storytellers among us, for those who look upward at night with wonder, it felt more like an entrance on a cosmic stage. FA22 did not appear alone. Its timing was too perfect, its presence too well placed, as though waiting for its cue. 3 days earlier, on September 15th, a smaller rock, 2025 RJ2, had brushed past even closer, a mere 300,000 kilometers from our planet. That is less than the distance from here to the moon. Think of it, a handshake in the dark, a visitor approaching the door of Earth's house and then vanishing again without knocking. To see one asteroid is common. To see two, arriving within days of each other, already suggested a pattern. And then, more appeared. Dozens of objects, each weaving their paths across the night sky, all within a short span of time. Observatories tracked them relentlessly, feeding their data into international databases, confirming orbits, calculating distances. Yet beyond the spreadsheets and numbers, a sense of unease stirred. It was not fear these were safe encounters, after all, but a strange awareness. The sky was not behaving like its usual self. It felt almost choreographed. Imagine a parade, not of flags and music, but of silent stones drifting past at thousands of kilometers per hour. Each one seemed to follow the other, like lanterns released into the night. The universe, normally so vast and empty, suddenly appeared crowded. In history, humanity has often read meaning into such gatherings. The Romans might have whispered of omens. The Mayans might have carved new glyphs, seeing messages in the stars. Even in medieval Europe, clustered celestial signs were taken as warnings of plagues or wars. And yet here we were, in the 21st century, equipped with advanced telescopes, radar, and supercomputers, and still, some part of us felt the same old stirring. Is this just coincidence? Or something more? For those awake in the small hours, telescopes pointed skyward, became like instruments tuned to a quiet symphony. One astronomer in Chile described it in her notes. It feels as though the heavens are breathing more quickly, exhaling stones and fire. Another, in Japan, compared the clustering to the beating of drums before a grand performance. These were scientists, trained in data and measurement, yet their language reached for poetry, because sometimes numbers alone cannot capture what the heart perceives. To the casual observer, FA22 was invisible. It did not blaze across the sky like a meteor. It did not leave a trail like a comet. It was silent, unseen, its presence known only through instruments. But imagine standing outside on a clear September night, breathing the crisp air. Somewhere up there, a mountain of rock was gliding past, unannounced, unnoticed, as though the universe itself had placed a stone near our doorstep and waited to see if we would notice. If you close your eyes, you can picture it. The asteroid, cold and pitted, tumbling slowly as sunlight glints off its surface. Craters carved by ancient collisions mark its skin like scars of forgotten battles. It has no intent, no awareness, and yet its passing leaves an echo, a question in the mind. How many such stones sail past unseen? How many silent parades slip through the darkness while we go about our daily lives? The truth is humbling. At any given moment, thousands of near-Earth objects are moving around us. Most are small, harmless, no larger than grains of sand, burning harmlessly in the atmosphere as shooting stars. But some, like FA22, are large enough to matter, reminders of Earth's vulnerability in a cosmic shooting gallery. We sleep easily only because the vastness of space keeps most of them at bay. But the September clustering felt different, not a single stone, but a chorus. And so, the story of FA22 became more than a line in an astronomical bulletin. It became the opening drumbeat in a larger cosmic performance. Each object that followed seemed to take its place in line, as though answering a call. Was it merely probability playing tricks on us? Or was there a rhythm hidden in the dark, one we were only just beginning to hear? As days passed, the media picked up the story. Headlines spoke of close calls and near misses. Readers scrolled, shrugged, and went back to their routines. But in observatories and living rooms, where sky watchers gathered, the sense of awe grew. Not dread, not panic, but something quieter. The recognition that we live in a neighborhood that is alive, shifting, and more crowded than we imagined. And behind this parade of stone, waiting patiently in the wings, another performer prepared to step forward. Not a mountain from our asteroid belt, not a comet from our Oort cloud, but something stranger. An interstellar traveler carrying the chemistry of another world, older than Earth, older than the Sunday. The stage was growing crowded. The curtain was lifting higher. The true drama was only beginning. The days around mid-September became a kind of whispered conversation between Earth and the cosmos. One object after another brushed past, almost as if the universe were extending its hand, offering a silent greeting in the night. These encounters were not catastrophic, not even threatening. They were simply close enough to feel uncanny, like strangers passing us on a quiet road, their shoulders nearly brushing ours before they disappeared into the dark. The most striking of these moments was the passage of 2025 RJ2 on September 15th. It was not a giant like FA22. Smaller, less imposing, but somehow more intimate. At just 0.78 lunar distances, roughly 300,000 kilometers, it slipped by closer than the moon itself. Imagine standing in your garden and knowing that an object larger than a stadium had just moved past at cosmic speed, a mere breath away in astronomical terms. It was not seen by the naked eye, no glowing tail, no fiery streak, but telescopes knew. The data poured in, confirming what had happened, a handshake in the dark. These small asteroids are reminders of how crowded the space around us really. Island. We imagine the heavens as empty, endless, a void between stars. Yet here, so close to home, there is a kind of traffic, stones and fragments left over from the birth of worlds, wandering still. To the eye, the sky may seem tranquil. To the instruments, it is alive with motion. Throughout that same week, dozens of other visitors joined RJ2. Some passed at sublunar distances, some a little farther, each leaving its trace on the charts of astronomers. None collided, none threatened, and yet their clustering raised eyebrows. It was as though an unseen conductor had lifted a baton and called them into motion together. The effect was subtle, statistical, but it stirred the imagination. Think of it like lanterns drifting down a river at night. One lantern might seem ordinary, two, perhaps coincidence. But when dozens float past together, the sight becomes something else, an event, a gathering, a procession. That was what September 2025 began to feel like. A procession not of light, but of shadows, each object passing silently, yet each one hinting at a larger story. Ancient cultures would have seen signs in such clustering. In Mesopotamia, scribes would have etched omens onto clay tablets. In China, court astrologers would have rushed to the emperor, warning of shifts in heaven's mandate. Even in medieval Europe, chronicles would have recorded strange apparitions and tremors in the sky. For us, in the modern age, the interpretation is less mystical and more mathematical. Yet even now, we cannot fully quiet the human instinct to search for meaning. And so scientists found themselves caught between two voices, the rational voice reminding them that improved surveys reveal more objects than ever before, and the poetic voice whispering that perhaps something larger was unfolding. Both voices are part of us. Both deserve to be heard. A young astronomer at the Vera Rubin Observatory wrote in her logbook, "It feels as though the sky has grown busier, as though the Earth is moving through a crowded avenue instead of an open field." Another observer in Hawaii described the week as a dance of stones, close enough to feel, yet far enough to remain only a memory. These are not official reports, but personal impressions. And they matter, because they remind us that science is not only about data, it is also about wonder. Picture yourself lying back on a hill beneath the stars. You cannot see RJ2 or the others that came with it. They pass in silence, invisible to the naked eye. Yet above you, these wanderers move in patterns that defy our sense of emptiness. You breathe in the cool night air, and though you may not notice it, your planet is surrounded, touched, brushed by ancient fragments whose journeys began long before humanity walked the earth. And perhaps this is the most humbling thought, that these handshakes are not rare. They happen constantly. The difference now is that we can finally see them, with new observatories scanning the skies every night. What once seemed like rare anomalies now appear as frequent, almost routine encounters. We are not suddenly more endangered. We are simply more aware. Yet awareness changes us. Once you know that the night is alive with unseen visitors, you never look at it the same way again. The sky ceases to be a blank canvas. It becomes a page filled with motion, margins crowded with stories. And in September 2025, those stories began to feel like chapters in a larger book. Because while RJ2 and its companions passed us safely, their timing hinted at something more. Behind them, looming like an unseen character waiting to enter, was another presence, one not bound to our sun, one carrying chemistry unlike any comet or asteroid we had ever studied. The small handshakes were preludes. The true meeting was still to come. And so, as FA22 drifted away, as RJ2 slipped silently past, as the charts filled with new dots and lines, astronomers lifted their gaze a little higher, aware that the real drama had not yet begun. The stage was crowded, the curtain rising, and from beyond the boundaries of our solar system, a new actor was stepping into view. While asteroids moved like silent stones across the stage, another performer was preparing a more luminous entrance. On September 11th, 2025, a faint smear of light was noticed by the Solar and Heliospheric Observatory SOHO for short. Its Swan instrument, designed to trace hydrogen emissions, had stumbled across something else, a comet, new and fragile, slipping inward from the cold reaches of space. Its name, technical though it sounded, C, divided by 2025 R2, Swan, would quickly become something more poetic as observers realized what was happening. Comets are not like asteroids. Where asteroids are mountains of rock, comets are snowballs of ice and dust, fragile and transient. As they fall sunward, they ignite not with fire, but with sublimation, their frozen interiors unraveling into glowing comas and sweeping tails. This is what Swan began to do, quietly at first, then more boldly as September unfolded. Its tail stretched across the evening sky like a painter's brushstroke dipped in light, delicate, wavering, yet unmistakable. Those who knew where to look could already glimpse it near Virgo, not far from Spica, that bright jewel of the constellation. For the casual stargazer, it was a smudge barely above the threshold of naked eye visibility, but for those with binoculars or telescopes, it was a living canvas. The coma glowed with faint green tones, ghostly, otherworldly, while the tail fanned outward, pointing away from the sun, as if in silent surrender. Think of the scene, twilight giving way to darkness, and there, above rooftops or deserts or seas, a luminous brushstroke written across the heavens. The ancients would have fallen to their knees, reading portents in its glow. In Greece, comets were hairy stars, messengers of divine displeasure. In China, they were scythes in the sky, blades of heaven that cut through dynasties. To the Maya, they foretold upheaval, sometimes rebirth. Even today, when we know comets as natural wanderers of the Oort cloud, some quiet pulse within us still hears them as omens. Yet Swan was not threatening. It was fragile, perhaps too fragile. Many such comets do not survive their first close passage to the Sunday. Their icy hearts crack, their bodies fragment, until they dissolve into meteoric dust. Would Swan endure? Or would it break apart, leaving only a ghostly cloud as its memory? The question lingered as September's nights grew longer. Astronomers watched with careful anticipation, adjusting their instruments, logging every brightening. Each night, Swan seemed to shimmer a little more strongly, as if gaining confidence. Photographers in rural fields captured long exposures, showing its tail stretching farther, becoming more structured, like a banner unfurled in the wind of solar radiation. For those who looked, it was a spectacle, a gift in the sky. For those who did not, it passed silently, as comets often do here for a moment, then gone, their visits briefer than human lives. And yet, Swan was more than spectacle. It was also a clue. Comets carry chemistry older than Earth, frozen samples of the early solar nebula, preserved in deep freeze for billions of years. When they release gas and dust, they spill secrets ratios of water to carbon dioxide, traces of organic compounds, hints of how worlds form. In that sense, Swan was not just a painting in the sky. It was also a letter, written in ancient chemistry, drifting into human hands for a brief time before vanishing again into silence. This is why scientists pay attention. Every comet is both fragile beauty and deep archive. Imagine, then, the tension of watching Swan, a jewel from the outskirts of our solar system, glowing for the first and perhaps the last time. If it survived perihelion, its story could be read more clearly. If it broke apart, the story would scatter into countless fragments, each one a word lost in the wind. For the people who went outside to look, the comet gave something else: stillness. You did not need to be a scientist to feel it. Standing in the cool September air, seeing a pale green smear above the horizon, you might feel time slow. You might imagine yourself not just in your city or your home, but in the universe itself, part of something older and wider. A comet reminds us that we live in motion, that our sky is not fixed, but alive, constantly rewritten by wanderers that come and go. And so, in September 2025, Swan's tail became a brushstroke on the cosmic canvas, one painted in the same weeks that FA22 and RJ2 passed by. The coincidences grew harder to ignore. A stone here, a brushstroke there, and waiting in the wings, the interstellar visitor still approaching. If the asteroids were the drums of the performance, Swan was the violin, delicate and haunting, filling the silence with color. Not everyone noticed. Cities glowed too brightly, and most lives were too busy. Yet those who did notice became part of an unspoken fellowship, sky watchers, strangers who share a glance upward and feel connected. A farmer in Morocco, an amateur astronomer in Finland, a photographer in Chile, all looking at the same faint smear of light, knowing it was not permanent, knowing it was something fragile and rare. Perhaps this is why comets have always stirred our myths. They remind us of impermanence, of beauty that does not last, of the fleeting chance to witness something extraordinary. Swan might survive, Swan might vanish, but in either case, its presence was enough to remind us that the universe is not static. It moves, it breathes, it writes new stories even as we sleep. And behind Swan, beyond the comet's green shimmer, another light was gathering strength. 3, I divided by Atlas, the interstellar traveler, was still hidden, its glow faint but undeniable. Swan was the overture, the delicate prelude. The main act had not yet begun. While Swan shimmered faintly in twilight, another figure lingered farther away, darker, heavier, more patient. Unlike FA22 or RJ2, it was not a fleeting guest of September. Unlike Swan, it did not trail a luminous tail across the sky. Instead, it waited with the stillness of something ancient, something destined. Its name is Apophis, officially catalogued as asteroid 99942, a mountain of rock over 400 meters wide. And though it moved slowly across our charts in 2025, astronomers' eyes were already looking ahead to April of 2029, when Apophis will pass closer to Earth than many of our satellites. The very name Apophis stirs something in us. It was borrowed from Egyptian mythology, where Apophis or Apep was the serpent of chaos, the eternal enemy of the sun god Ra. Each dawn, Egyptians believed, Ra's solar bark sailed through the underworld, fending off Apophis's attempts to devour the light. For them, the serpent symbolized the endless struggle between order and chaos, light and shadow. How fitting, then, that this asteroid, destined to sweep so close to our planet, carries that name. It feels almost as if myth and astronomy had conspired to remind us of our fragility. In 2025, Apophis was still years away from its rendezvous, yet every astronomer knew its importance. Unlike most near-Earth objects, its orbit has been studied in exquisite detail. Radar observations from Arecibo and Goldstone in past decades traced its path so precisely that the risk of collision once feared was ruled out. Apophis will not strike Earth in 2029, nor for at least a century afterward. And yet, the encounter remains one of the most remarkable events in human history. A visible, naked-eye asteroid, brighter than many stars, rushing past at 50,000 kilometers per hour, only 32,000 kilometers from Earth's surface. To imagine its closeness, picture this. Geostationary satellites orbit at about 36,000 kilometers, hovering above the same patch of Earth. Apophis will pass even closer. Closer than the machines that carry our phone calls, weather data, and internet signals. It will be visible not through telescopes, but directly, a bright moving star, racing across the heavens, fast enough that anyone looking up can watch its motion in real time. In September 2025, as FA22 and RJ2 brushed past, as Swan brightened, Apophis loomed in the background of every report. Like a giant waiting in the wings of the cosmic theater, it was silent, biding its time, but its future role was already assured. And this gave September a curious texture. It was not only about what was happening, but what was yet to come. The clustering of asteroids and comets seemed to foreshadow the giant's approach, a rehearsal before the main act years away. Scientists prepared carefully. NASA's OSIRIS-APEX mission, once a sample return spacecraft, had been redirected to rendezvous with Apophis shortly after its 2029 flyby. Its task would be to measure changes in the asteroid's rotation, surface features, and internal structure caused by Earth's tidal pull. For Apophis will not leave this encounter unchanged. As it skims past, Earth's gravity will reach into it, tugging at its rotation, shaking loose regolith, perhaps even triggering landslides across its slopes. The asteroid that departs will be measurably different from the one that arrives, a reminder that even solid rock yields to invisible forces over time. From a poetic view, this feels almost like myth reborn. The serpent Apophis will coil close to Earth, but rather than devouring the sun, it will be reshaped by our planet's pull. Chaos meeting order once again, not in ritual or legend, but in orbital mechanics written across the sky. Imagine yourself in 2029, standing under the stars, looking up as Apophis blazes across the heavens. You would see it with your own eyes, brighter than most stars, moving so swiftly that it could be tracked without instruments. Children would point, cameras would record, and for a brief night, humanity would share the same spectacle. It would not be a comet's brushstroke, fragile and uncertain, but a mountain of stone rushing by, immense and indifferent, reminding us of what it means to live on a planet exposed to the cosmos. In 2025, however, it remained distant, quiet, a sleeping giant. But its presence colored the conversations around September's surge. If so many smaller objects could arrive together now, what did it mean that a true giant was already on its way? Was the clustering coincidence, or part of a larger pattern we did not yet understand? Some astronomers dismissed such thoughts as apophenia, our human tendency to see patterns where none exist. Others, more philosophical, suggested that perhaps the cosmos was reminding us that vigilance matters, that we live not in isolation, but in a galaxy where chance encounters shape destiny. For every quiet September, there may come a louder one, and Apophis embodied both the reassurance of safety and the reminder of possibility. In mythology, Apophis was never fully destroyed. Each dawn, Ra defeated him, yet each night he returned. So too with the asteroid. It will not strike us in 2029, but it will return again and again, looping through time, approaching, retreating, approaching again. Perhaps someday, long after we are gone, its path might intersect differently. Or perhaps humanity will have grown wise and capable enough to guide such bodies gently away, transforming threats into opportunities. As you picture Apophis in the quiet dark of 2025, imagine it not only as a rock, but as a teacher. It shows us scale the immensity of what drifts around us. It shows us impermanence, that even giants can be reshaped by invisible pulls. And it shows us connection, that our planet, our fragile Earth, is not apart from these bodies, but engaged with them, sharing gravity, light, and destiny. And so, as the September parade unfolded, Apophis lingered as the silent drumbeat beneath the melody. The asteroids that brushed by were whispers. The comet Swan was a brushstroke, but Apophis was the giant, resting backstage, waiting for its cue. And behind even him, something stranger still approached, a visitor, not bound to our sun at all. The true mystery of 3I divided by Atlas was waiting, and the stage was almost ready for its arrival. Beyond the asteroids that brushed past in September, beyond the fragile shimmer of Comet Swan, something more elusive was drawing closer. It did not come from the asteroid belt between Mars and Jupiter. It did not descend from the frozen shell of the Oort cloud. It was not born under the warmth of our sun at all. It came from elsewhere, perhaps light years away, perhaps from a star long dead. This was 3I divided by Atlas, the third confirmed interstellar object in human history. To imagine such a thing is to stretch your sense of place. Every comet and asteroid we have ever studied belongs to our solar family. They orbit, sometimes chaotically, but always bound by the gravity of our star. Even the most eccentric paths eventually turn back, pulled homeward. But 3I divided by Atlas is different. Its orbit is not closed. It is hyperbolic, meaning it will not return. It has enough velocity to break free forever, to come and go without being captured. It is a visitor, not a resident, and once it departs, we will never see it again. The Atlas survey team in Chile first noticed it on July 1st, 2025. At first, it was just another faint dot in a sky filled with countless dots. Software flagged it for follow-up because its motion seemed unusual. Astronomers turned their telescopes toward it, expecting to confirm another ordinary comet or near-Earth asteroid. But as the days passed and the numbers sharpened, something extraordinary became clear. The eccentricity of its orbit was greater than 1, the unmistakable signature of an interstellar origin. For scientists, it was a moment both thrilling and humbling. To catch sight of an interstellar traveler is to receive a message written not just in another language, but in the alphabet of another world. Before 3I divided by Atlas, there had been only 2 others. 1I Oumuamua in 2017, and 2I divided by Borisov in 2019. Each had startled us, but each had also left quickly, too quickly for detailed study. This new visitor seemed different. Its trajectory, its timing, and its chemistry promised a longer encounter, a more generous gift. Picture it now. A nucleus, perhaps a few kilometers wide, wrapped in ice and dust that has not felt the warmth of any sun for billions of years. As it approaches ours, Its frozen skin begins to stir, exhaling vapor, creating a faint coma. Under telescopes, it does not shine with steady light, but with the soft blur of activity, a halo that whispers of its alien chemistry. And indeed, when spectrographs measured its glow, they found something startling ratios of carbon dioxide to water, unlike any comet we have ever known. In a sense, it carried a recipe foreign to our kitchen of planets, as if its home system had followed a different cookbook of creation. Such details may sound technical, but they carry immense weight. To astronomers, they are more than numbers. They are glimpses into the conditions of another star's nursery, a chance to study matter formed in a place our spacecraft may never reach. Imagine finding a bottle washed up on a beach. Inside is a fragment of a letter written in a script you barely understand. You may not know who sent it, or from where, but you know it has crossed an ocean, perhaps many oceans, to reach you. That is what 3, I divided by Atlas, represents a message in a cosmic bottle, tossed from the shores of another Sunday. And the timing seemed uncanny. Just weeks after the September parade of asteroids and comets, this interstellar visitor approached perihelion, its closest point to the Sun, on October 30th. Too perfect, some whispered, as though the universe had staged the show, building anticipation with familiar performers before unveiling the rarest of guests. But here is the paradox. Though 3, I, divided by Atlas, is extraordinary, it is also ordinary in another sense. Theory tells us that every planetary system ejects countless small bodies during its birth. Giant planets sling them outward like pebbles from a sling, some falling into distant orbits, others flung entirely free into the galaxy. There should be trillions of such wanderers, drifting between stars. That we have only spotted 3 so far says less about rarity and more about our blindness. We are only just beginning to open our eyes. Still, awareness does not blunt wonder. To stand under the night sky in September 2025 was to feel the weight of coincidence. FA22 had passed, RJ2 had brushed close, Swan had brightened, Apophis loomed in the future, and now this, a messenger from beyond, arriving just as our instruments had become sensitive enough to notice. A child looking up might think, it came for us. A scientist might reply, it came by chance. And somewhere between those voices lies the truth. It came, and that is miracle enough. Imagine yourself as one of the astronomers in Chile on the night of its discovery. You are tired. Your coffee is cooling on the desk. The air outside is crisp and thin. You watch the data scroll across your screen, lines of numbers, tiny increments of movement. At first, it seems ordinary. Then the math insists otherwise. Your heart quickens. You realize you are among the first human beings to recognize an object, not of our solar family, but of another, older one. You look up at the stars, and for a moment, they seem closer, as though the galaxy itself had leaned down to whisper in your ear. This is what makes 3, I divided by Atlas, the stranger from afar. Not its danger, it poses none. Not its size, it is modest. But its story. It has traveled perhaps billions of years to reach us, carrying chemistry unspoiled by our sun, bearing witness to conditions that no probe we launch could yet explore. It is, in the quietest sense, an emissary. As it drew closer, in the autumn of 2025, telescopes prepared to lose sight of it behind the sun's glare, knowing it would reappear in December. Patience was required, but patience is the astronomer's gift. When it emerged again, it would be brighter, better placed for study, ready to yield secrets. But even in September, its presence was felt. Like a shadow approaching from the edge of the stage, not yet visible to the whole audience, but sensed, awaited, inevitable. And so, while Swan painted its brushstroke, and Apophis dreamed in silence, the true stranger was stepping forward, an object not of here, but of elsewhere, a fragment of another world, drifting into ours for the briefest of visits before continuing on, never to return. The September sky was no longer just busy. It was enchanted, threaded with connections across time and space, preparing us for the moment when the interstellar traveler would stand, unmistakable, in the spotlight. When astronomers first began analyzing the light of 3I, divided by Atlas, they expected the familiar signature of comets' water ice vaporizing, mixed with a modest blend of carbon dioxide, dust, and trace metals. But almost immediately, the spectrum told a different story. The ratios were all wrong. Instead of water leading the composition, carbon dioxide dominated. It was not just unusual, it was nearly impossible by the standards of our solar system. To understand why, picture how comets form. In our own solar nursery, billions of years ago, water condensed from the solar nebula in regions about 2 or 3 astronomical units from the Sun, roughly where the asteroid belt is today. Carbon dioxide, with its lower freezing point, formed farther out, beyond 10 astronomical units, in the realm of the gas giants. This meant that most comets, whether from the Kuiper belt or the Oort cloud, carry water as their main ingredient, with carbon dioxide as seasoning, never the main course. But 3I divided by Atlas reversed this recipe. Its chemistry suggested it was born in a place so cold, so remote, that water never gained dominance. Imagine baking bread with no flour, only spices, strange, incomplete, and yet still real. That is what 3I divided by Atlas seemed to be. A comet made of ingredients familiar in isolation, but in proportions that made no sense. It was like tasting a dish from another culture, one that had evolved under different conditions, and realizing you were sampling flavors entirely alien to your palate. The James Webb Space Telescope confirmed this strangeness. Its infrared instruments revealed one of the highest carbon dioxide to water ratios ever seen in a comet. At the same time, data from Chile's Very Large Telescope added another twist: strong nickel emissions, but curiously weak iron. Normally, comets reflect the balanced abundances of the stars that birthed them, where iron and nickel march hand in hand. But here, the balance tilted. Nickel was prominent, iron subdued. It was as though some cosmic hand had edited the recipe, crossing out one ingredient while doubling another. What could this mean? Perhaps 3I divided by Atlas had formed around a star with unusual chemistry, in a galactic neighborhood poor in iron but rich in other metals. Or perhaps, during its billion-year journey through interstellar space, cosmic rays had chipped away at its iron, leaving nickel behind. High-energy radiation can sculpt matter over vast timescales, slowly altering surfaces, atom by atom. The result, seen billions of years later, is a signature that makes sense nowhere, but in the silence between stars. The strangeness deepened as September turned to October. Observers reported that the comet's tail was not simple, but layered. One plume stretched in the classic direction, away from the sun, while another seemed angled oddly, hinting at jets erupting from beneath its crust. These outbursts were irregular, pulsing like breath. Sometimes the comet brightened suddenly, then dimmed again, as though its heart were beating to rhythms no one could predict. Picture it, a nucleus black and rugged, turning slowly in the dark, fissures opening like mouths, spewing jets of gas that scatter dust across millions of kilometers. The sunlight catches those grains, bending them into glowing streams that arc like silk ribbons in the wind. Through a telescope's eye, it is not merely science, it is spectacle, alive, moving, speaking in a language of vapor and light. The behavior challenged every assumption. Most comets follow predictable curves of brightness as they approach the sun, glowing steadily more as the heat rises. But 3I divided by Atlas defied that pattern, flaring unpredictably, as though carrying hidden reserves of volatile material that ignited only when some fragile crust gave way. It was both comet and trickster, offering glimpses and then retreating, never quite fitting the mold. Scientists debated fiercely. Was its chemistry a clue to its birthplace, perhaps a thick disk star system older than our Sun? Or was it a record of survival, shaped by eons of interstellar travel? Was it ancient or merely unusual? Each possibility carried implications that stretched far beyond a single comet. If systems across the galaxy create such objects, then planetary formation is more diverse than we ever imagined. If not, then perhaps we had stumbled on a true rarity, a cosmic outlier. And yet, beyond the data and theories, something more subtle stirred in those who watched. It was not only about molecules and ratios, but about perspective. To gaze at 3, I divided by Atlas, was to realize that the familiar recipes of our home system are not universal, that the way water, rock, and metal came together here is only one possibility among many. Out there, in the cold reaches of other suns, other combinations take shape. Other worlds may have risen, other chemistries may have brewed, other stories may have begun. In ancient myths, the strange was always a messenger. A green light in the sky was a warning. A serpent-shaped star was a prophecy. Today, we translate those messages into graphs and spectra, but the awe remains. 3, I divided by Atlas, with its impossible chemistry, reminded us that the universe is still filled with recipes we have not tasted, languages we have not learned. As October approached, and the comet edged closer to the Sun, it grew harder to see, swallowed by solar glare. Yet its secrets lingered in the data, waiting for December's reappearance. And already, whispers of speculation spread. If its chemistry was this strange, could it hold more surprises still? Was it natural, or could there be other explanations, stranger still? For now, the answer was simple. 3, I divided by Atlas, was unlike anything we had seen before. A comet, yes, but also a riddle, written not in words but in the ratios of molecules and the shimmer of tails across the night sky. And as with all riddles, the question was not just what it meant, but what it revealed about us, that we are still learners, still wide-eyed children beneath the vault of stars, humbled and amazed by visitors that wander in from the dark. FA-22 had passed safely. It had sailed by at 835,000 kilometers, a distance wide enough to assure scientists, narrow enough to stir headlines. But what if it had not? What if, instead of missing us by 2 lunar spans, it had aimed directly for our world? The mathematics of such a collision are unforgiving. A mountain-sized object, traveling at over 10 kilometers per second, carries an energy release of 100 megatons of TNT, 2,000 times the bomb that destroyed Hiroshima. Numbers alone tell part of the story. The rest requires imagination. Close your eyes and picture the sky above you, quiet, familiar. Then imagine a new light swelling suddenly, brighter than the Sunday. That light would be FA-22 entering Earth's atmosphere, compressing air ahead of it into plasma hotter than fire, glowing like a second star. From hundreds of kilometers away, you would see the flash, a brilliance too fierce to gaze upon, a radiance that burns retinas and ignites forests in an instant. If the asteroid were stony, it might shatter before touching ground. High above the surface, at 5 to 15 kilometers altitude, the airburst would unfold. The shock wave would tear outward, shattering windows over entire countries, flattening towns within 50 kilometers, toppling trees in waves that ripple across the landscape. Tunguska, in 1908, was a fraction of this scale, and yet it leveled 2,000 square kilometers of forest. FA-22, far larger, would carve devastation across entire regions. The sound would arrive moments later, a thunderclap stretched into minutes, echoing like the voice of the planet itself in pain. Now imagine a denser body, one made of iron. Instead of breaking apart, it would punch through the air, slamming into Earth with enough force to gouge a crater 3 kilometers wide, half a kilometer deep. Rock would vaporize, soil would liquefy, shock waves would ripple through the crust. The ground would tremble like a bell struck by a hammer, registering as a magnitude 6 earthquake on seismographs across continents. The impact would hurl molten debris high into the atmosphere, raining fire for hundreds of kilometers, setting fields, forests, and cities alight. For those within view, it would feel like the sky itself was falling. And yet, there is an even more haunting possibility. Ocean impact. With water covering 70% of our planet, this is statistically the most likely outcome. Picture FA-22 plunging into the Atlantic, releasing energy in the deep sea. The water would not swallow it quietly. Instead, colossal plumes would rise, followed by tsunamis hundreds of meters tall at their source. These waves would spread across the ocean basin, flattening into 10 or 20-meter walls of water as they reached coastlines. Hours after the impact, cities from Boston to Barcelona, from Casablanca to Rio, could be swallowed by waves taller than buildings, sweeping away everything in their path. Scientists note that such waves lose height with distance, that coastal geography can blunt or amplify their force. But for those standing at the shore, details hardly matter. The sea would withdraw first, exposing seabeds eerily bare, fish flopping helplessly on sand. Then, on the horizon, a wall would rise, advancing silently until its roar became deafening. There would be no time to run, only to witness the ocean transformed into a weapon. And yet, paradoxically, even such devastation would remain regional, not global. Humanity, spread across continents, would endure. Civilization might stagger, but it would not end. Extinction requires larger objects, kilometer-scale giants that strike only once every 500,000 years or so. FA-22 was not that. It was a city killer, a nation breaker, but not a world destroyer. Still, the lesson is sobering. For while FA-22 did not strike, others have. 65 million years ago, an asteroid 10 kilometers wide ended the reign of dinosaurs, darkening the skies for years, collapsing ecosystems, giving mammals their chance to rise. Smaller strikes have scarred our planet countless times, leaving craters now softened by erosion, reminders etched into stone that the heavens sometimes fall. What makes FA-22 haunting is not its size alone, but our blindness. We saw it because our instruments happened to notice, but what of those we miss? The Chelyabinsk meteor in 2013 was only 20 meters wide, and it still injured over 1,000 people when it exploded above Russia. It approached from the direction of the sun, hidden in glare, undetected until it arrived. If FA-22 had come that way, would we have been ready? Could we have acted in time? These are the questions that echo in the minds of planetary defense teams. And yet, even here, there is comfort. For the very act of imagining these scenarios, of running simulations, of planning deflections, means we are not helpless. We have nudged an asteroid before NASA's DART mission proved it in 2022. We are learning to see farther, to catalogue more. Knowledge is our shield, and imagination our practice ground. To wonder, what if, is to prepare for when. So let the vision of FA-22's possible impact linger, but gently, like a dream half remembered. Think of the light in the sky, the roar of air, the trembling ground, the rising sea. Then let it fade, replaced by gratitude that it did not happen, that our September remained only a rehearsal. FA-22 passed by, and the world slept peacefully, unaware of the drama that might have been. And as the stone faded into darkness, another story gathered strength. For even as we imagined what could have been, another performer was already stepping forward, the interstellar stranger, whose chemistry defied expectation, whose presence seemed timed too perfectly to ignore. September's stage was not done. The parade of stones was only the opening act. If the sky ever sends a stone into the sea, the story it writes will not stay at the impact site. It will ripple outward, carried by water, reshaping entire coastlines. In many ways, this is the most likely fate of an asteroid large enough to matter. 70% of Earth's surface is water, and oceans are wide targets. When a body like FA-22 meets the sea, the result is not a splash, but a transformation, an energy release so vast it changes the ocean itself. Imagine, for a moment, the quiet of a calm morning on the Atlantic. Waves lap gently, gulls wheel overhead. The horizon is a perfect line of silver blue. Then, in an instant, the sea convulses. A mountain of stone slams into deep water at 10 kilometers per second, transferring more energy than all the nuclear weapons ever built. The water cannot absorb it quietly. Instead, it heaves upward in a plume, hundreds of meters high, a tower of sea and spray clawing at the sky. Beneath, shock waves spread through the water like a bell rung with terrible force. From that wound in the ocean, waves begin to race outward. At the source, they rise to over 100 meters, sheer walls of water. As they move, they flatten, but they do not weaken quickly. Carried at jet speeds, they cross ocean basins in hours, still towering when they reach faraway shores. A 10-meter wall of water does not sound large in the vastness of the sea, but picture it rising at the edge of a city. 10 meters is taller than most buildings along a coastline, high enough to sweep cars, bridges, homes, and lives into the flood. The physics is complex. Wave heights diminish with distance, shaped by seafloor contours and coastal geography. A bay can amplify them, funneling energy inward, while a broad, shallow shelf may blunt the blow. Yet in all models, one truth holds: ocean impacts turn local events into global ones. A crater in rock may scar a region. A crater in water moves the sea itself. History holds whispers of such events. Around 1500 BCE, the eruption of Thera in the Aegean Sea triggered tsunamis that battered Crete, undermining the Minoan civilization. In 1883, Krakatoa's volcanic explosion sent waves surging into coastlines, killing tens of thousands. And yet, these were volcanic, not cosmic. Asteroid-driven tsunamis would dwarf them. A stone from the sky does not merely explode. It forces the ocean to rise and fall, as though Earth itself were shuddering. Now imagine an FA-22-sized rock landing in the mid-Atlantic. Within hours, the coastlines of Europe, Africa, and the Americas would all feel its reach. Cities like Lisbon, Dakar, Rio de Janeiro, and New York would see the sea recede first, drawn outward in eerie silence. Beachfronts would stretch unnaturally far, seabeds glistening in sunlight where fish flopped helplessly. Those who lingered would then see it, a wall rising on the horizon, advancing with a speed that made escape impossible. Its roar would grow until it became indistinguishable from thunder. Then it would arrive, a moving cliff of water swallowing streets and harbors, carrying ships far inland, leaving behind wreckage where neighborhoods once stood. And this, chillingly, would not be a worst-case scenario. Larger impacts, kilometer-sized objects, could trigger waves that circle the globe, devastating coastlines on every continent. For comparison, scientists note that one of Earth's great mass extinctions may have been worsened by such waves. When the Chicxulub impact ended the age of dinosaurs, it not only darkened skies with dust, but sent tsunamis tens to hundreds of meters high, racing across oceans. What fire did not burn, water finished. Yet here too, Perspective matters. Impacts of that scale are rare, once every few 100,000 years or more. City-killer asteroids, like FA-22, are far more common. Yet even they would devastate only regions, not the entire world. Civilization might stumble, but humanity would endure. The ocean would heal, coastlines would rebuild, and stories would remain, passed down as memories of the day the sea rose higher than any mountain. For millennia, myths have hinted at such floods. In Mesopotamia, the Epic of Gilgamesh tells of waters that swept across the land. In the Hebrew Bible, Noah survives a deluge sent to cleanse the earth. In Hindu lore, Manu is warned by a fish to build a boat before the cosmic flood. In each case, the flood is more than water. It is a reckoning, a reminder of fragility, a story told and retold until it becomes part of our collective memory. Perhaps these myths are not literal accounts of asteroid impacts, but perhaps, deep within human history, floods triggered by quakes, eruptions, or even celestial debris shaped our imagination. Water remembers, and so do we. Lying in bed tonight, listening to the quiet, it may feel unsettling to imagine such waves, yet in a strange way, the thought can also soothe. For we know now that we are not powerless. We are learning to detect these bodies years in advance. We are developing the means to deflect them. The very act of telling these what-if stories strengthens our readiness. And readiness itself is a comfort. Picture yourself at the shore once more. The tide is calm, the air salty and cool. You know the sea holds memories of ancient convulsions, yet tonight it is peaceful, reflecting the stars above. FA-22 passed us by. The water did not rise. The world remained whole. But in imagining what could have been, you glimpse both the power of the cosmos and the resilience of humanity. And behind this imagining, another thought emerges. What of the interstellar traveler, still approaching, its chemistry stranger than any comet before it? While we consider the might of asteroids and the fury of tsunamis, 2 please, I divided by Atlas, carries something quieter, but no less profound secrets of worlds beyond our own. The September parade showed us the dangers of stones. The stranger from afar promised something else, knowledge. Not all cosmic encounters arrive as mountains. Sometimes they come quietly, smaller than we expect, slipping past our watch until the very last moment. On the morning of the 15th of February 2013, the people of Chelyabinsk in Russia awoke to an ordinary winter's day. Snow covered the streets. The cold air bit at windows. Children prepared for school. Then, without warning, the sky lit up. What streaked across those skies was not large, only about 20 meters across, a fragment compared to giants like FA-22 or Apophis. Yet its speed, nearly 20 kilometers per second, turned it into a weapon forged by the cosmos. For a few heartbeats, it burned brighter than the sun, turning shadows sharp, leaving a glowing trail across the frosty heavens. And then, it exploded. At an altitude of around 30 kilometers, the asteroid fractured under pressure. The air itself became its hammer, compressing, heating, until the rock could bear no more. The energy released was equivalent to about 500 kilotons of TNT, 30 times the Hiroshima bomb. The blast wave raced downward, invisible, yet unstoppable. Windows shattered across the city, glass spraying into homes and classrooms. Walls trembled, car alarms wailed. Over 1,000 people were injured, not by fire or stone, but by shards of glass hurled inward by the shock. Dash cameras, common in Russian cars, captured the moment in eerie detail. Bright streaks, gasps, a sonic boom that arrived after the flash, rattling bones and hearts alike. These recordings spread across the world, a reminder that even in the 21st century, beneath satellites and supercomputers, the heavens can still surprise us. What makes Chelyabinsk haunting is not the damage it caused, but the fact that no one saw it coming. The asteroid approached from the direction of the Sunday. Our telescopes, peering outward at night skies, are blind to objects hidden in solar glare. By the time the stone revealed itself, it was already too late. There was no warning, no deflection, no chance for evacuation. The city simply bore the event, endured it, and learned from it. Scientists point to this as one of our greatest vulnerabilities, the sunward blind spot. If a larger asteroid were to come from that corridor, we might only know hours or minutes before impact. It is not a comforting thought, yet it is one we must face, for awareness is the first step towards safety. And so, Chelyabinsk became a catalyst. Governments accelerated plans for new survey telescopes. The European Space Agency expanded coordination networks. NASA's Planetary Defense Coordination Office gained urgency. And missions like NEO-Surveyor, an infrared telescope to be placed in space, able to see what Earth-bound instruments cannot move closer to reality. Out of broken windows came clarity. We cannot afford to be blind to the Sunday. But beyond the technical lessons, Chelyabinsk left a deeper echo. It reminded us that vulnerability can arrive from the most unexpected directions. Humanity, so often focused on conflicts between nations, discovered once again that the real threats may come from beyond, impartial and unannounced. The stone that flashed over Russia did not choose its target. It could have arrived anywhere: Tokyo, Cairo, New York, a quiet ocean, or an empty desert. Its indifference is humbling. Mythologies across cultures tell of fire from the heavens. The Greeks spoke of Phaethon, the reckless sun who drove the sun's chariot too close to Earth. In Norse tales, the sky itself cracks at Ragnarok, raining destruction. In indigenous traditions from the Americas and Australia, stories tell of falling stars that scar the land and change the people. When we see events like Chelyabinsk, we realize these are not just metaphors. They are memories, cultural echoes of encounters our ancestors once endured. Imagine standing in Chelyabinsk that morning. The air is cold. You tilt your head upward as the flash grows, thinking for a heartbeat that the world has caught fire. The boom shakes your chest, glass shatters, and fear floods your body. Then, just as quickly, silence returns. Life continues, though with bandaged hands and boarded windows. And yet, the memory lingers, an imprint as bright as the trail the meteor left across the sky. Now compare this to the September surge of 2025. FA-22, RJ-2, Swan, all tracked, all known, all safe. Contrast that comfort with the blindness of Chelyabinsk. One scenario shows the strength of our growing vigilance. The other reveals the fragility of our current systems. Together, they form a lesson. Progress is real, but gaps remain. And in those gaps lies both danger and mystery. Because while Chelyabinsk was natural, entirely explainable, the clustering of September objects and the arrival of 3.2.2, I divided by Atlas, invite questions we cannot yet answer. Coincidence? Pattern? Choreography? The echoes of one event reverberate into the next, each reminding us that the cosmos is never still. Perhaps that is why the Chelyabinsk story feels oddly reassuring when told at night. It shows us the scale of what could happen, but also the resilience of human communities. A city was shaken, but not destroyed. Lessons were learned, technologies advanced. The window shattered, but the world endured. And so, as you drift towards sleep, imagine the flash not as a threat, but as a reminder, a gentle tap from the universe saying, "I am here, I am active, and you must keep watch." The same message whispers through the September skies, through the brightening of Swan, through the strange chemistry of 3 I divided by Atlas. The heavens are not silent. They speak in fire, in light, in shadows that pass close and then vanish. And we, listening carefully, are learning their language. Imagine Earth at night, viewed from orbit. Cities sparkle with light, webs of civilization glowing against oceans and continents. But now imagine another layer, superimposed upon this view, silent trajectories of stones, comets, and debris threading their way across the sky. Some pass harmlessly, some skim close, and some, if left unseen, could one day intersect our fragile home. This is why we have begun building what scientists call our planetary defense system, humanity's neighborhood watch for the cosmos. For centuries, we had no watchman. Impacts were simply fate, as when the Chicxulub asteroid struck 65 million years ago, ending the reign of dinosaurs. But now, with telescopes, radars, and spacecraft, we can see farther, measure faster, and most importantly, act before it is too late. September 2025 proved that vigilance works. Dozens of objects passed through our neighborhood, each tracked, catalogued, and announced. FA22, RJ2, Swan, Apophis, all known, none ignored. This is progress. But progress is never complete. At the center of this effort is the Vera C. Rubin Observatory in Chile, a new giant eye on the sky. With its enormous mirror and wide-field camera, it can sweep across the heavens every few nights, capturing thousands of asteroids in each pass. In just its first 10 hours of operation, it discovered thousands of objects, many previously invisible to us. The cadence of its survey is a revolution. Where older telescopes might scan the sky once every few weeks, Rubin will do it every few nights. Patterns emerge faster. Threats are recognized earlier. What once was hidden is now seen. But Rubin is not alone. NASA's Near-Earth Object Surveyor, scheduled for launch in 2027, will watch from space itself. Unlike ground telescopes, it will not be blinded by daylight or weather. From its position trailing Earth, it will gaze outward in infrared, spotting the warmth of asteroids even when they hide in the sun's glare. This will finally close the blind spot that allowed Chelyabinsk to surprise us in 2013. With NEO Surveyor, the sunward corridor will no longer be a mystery. It will become another watched doorway in our cosmic neighborhood. Detection is only the first step. Once an object is found, it must be characterized, its orbit refined, its size measured, its composition guessed. These details matter. A loose rubble pile reacts differently to a push than a solid iron block. A shallow entry angle creates different damage than a steep one. Knowing the type of stone is as crucial as knowing its path. Networks of telescopes around the world, from Hawaii to the Canary Islands, cooperate to refine these measurements. Radar arrays, like those once operated at Arecibo and now expanded elsewhere, map surfaces with astonishing detail. Each observation is like a fingerprint added to the file of a potential cosmic visitor. And then comes the question, what do we do if a stone is coming? Here, humanity has begun to practice. In 2022, NASA's DART mission deliberately slammed a spacecraft into the small moonlet Dimorphos. The impact altered its orbit by over 30 minutes, proving that even a gentle nudge delivered years in advance can change a destiny. It was our first successful rehearsal of cosmic billiards, showing that we can redirect a celestial body with enough warning. Soon, the European Space Agency's Hera mission will arrive at Dimorphos to study the crater left behind, refining our models of how different kinds of asteroids respond to impact. Other techniques are imagined. Gravity tractors, spacecraft hovering near a rock for years, tugging it gently with their own small pull. Ion beam shepherds, firing streams of particles to nudge an asteroid without touching it. Even nuclear standoff devices capable of vaporizing surface layers to create powerful thrust. These are not fantasies. They are possibilities, each requiring preparation, coordination, and above all time. Lead time is everything. A nudge applied decades in advance can save the world with elegance. A desperate shove at the last moment may only fragment the danger into many smaller pieces. This is why international cooperation matters. No single country can protect the Earth alone. Asteroids do not respect borders. A stone that threatens Asia today might circle back to threaten the Americas tomorrow. The International Asteroid Warning Network exists for this reason, linking observatories, agencies, and scientists across the globe. When FA-22 briefly appeared on risk lists before its orbit was refined, this network became a stage for rehearsal. Data was shared quickly, updates published openly, and the potential for panic managed with caution. It was, in effect, a fire drill on a cosmic scale. Yet even in drills, weaknesses show. Communication was uneven. Some media outlets exaggerated the risk, others ignored it until after the danger passed. How do you tell the public about a possible impact without causing chaos? How do you balance transparency with the need for calm? These are not technical questions, but human ones, and they are as vital to planetary defense as telescopes or rockets. For in truth, planetary defense is more than science. It is psychology, politics, and philosophy. It requires trust between nations, belief in long-term preparation, and the humility to acknowledge that we are part of a larger system. It asks us to imagine futures where the difference between survival and catastrophe comes down to cooperation across oceans and decades. And here, in the quiet of night, this thought becomes strangely comforting. For once, the threats we face are not born of our divisions, but of the universe itself. The sky does not care about borders. It delivers stones impartially. And so perhaps, defending against them can remind us of what unites us. A shared world, a shared sky, a shared fragility. Picture again Earth at night, lights glittering like jewels. Now picture a faint net laid over those lights. Telescopes sweeping, satellites scanning, scientists sharing data. A neighborhood watch, not of fences and locks, but of awareness and readiness. A watch that lets us sleep more soundly, knowing that the heavens, though restless, are no longer entirely unmonitored. And somewhere in that watched sky, 3i divided by Atlas still glows, not a threat, but a messenger. Its chemistry whispers secrets from before Earth was born. Its tail sweeps like a brushstroke across darkness. It is not danger we prepare to deflect, but knowledge we prepare to receive. The same watchful eyes that track killers also welcome teachers. This, too, is part of our defense, not only shielding life, but expanding understanding. For to guard against the cosmos is to listen to it, to recognize that we are participants in its drama. The neighborhood watch does not merely protect, it connects. And in that connection lies both safety and wonder. Whenever something unusual appears in the heavens, two stories begin. One is written in numbers, spectra, orbits, velocities, probabilities. The other is written in whispers, rumors of cover-ups, hidden knowledge, secrets too dangerous for the public. These twin narratives have always followed comets and asteroids. They did in the days of ancient kings, and they do now in the age of satellites and smartphones. Consider the September surge of 2025. Scientists spoke of statistical clustering, better detection, the success of the Rubin Observatory. But on message boards, in late-night podcasts, in hushed conversations, a different tale took shape. What if we weren't told everything? What if FA-22 was closer than reported? What if 3i divided by Atlas was not just a comet, but a craft? The human mind, so finely tuned to pattern and agency, often seeks more than coincidence. It hungers for meaning. In some ways, this hunger is ancient. The Babylonians read omens in the paths of Venus. Medieval Europeans saw comets as divine warnings. In China, records of guest stars sometimes carried political weight, guiding emperors' choices. The sky was never only sky. It was message, mirror, threat, or promise. Today, though the language has shifted, the instinct remains. A comet with strange chemistry is not just a comet. It is, for some, a sign of alien technology. A cluster of asteroids is not just random. It is, for some, a cover story hiding something worse. The truth is both simpler and stranger. Simpler, because science reveals natural explanations for unusual behavior. Carbon dioxide dominance. In 3I divided by Atlas. Coincidental clustering from better surveys. Outbursts caused by volatile jets. Stranger, because the natural processes are themselves wondrous. A comet billions of years old, preserved since before Earth formed, is no less mysterious simply because no intelligence built it. And yet, conspiracy theories grow in the cracks between knowledge and uncertainty. Whenever scientists say, "We don't know yet," others rush to fill the silence with stories. Perhaps governments are hiding the truth to avoid panic. Perhaps militaries already have secret asteroid deflection weapons. Perhaps 3I divided by Atlas was deliberately sent. In that vacuum of certainty, imagination flowers wildly. The challenge is not that these ideas exist, but that they spread faster than truth. Social media amplifies them, carrying speculative videos farther than peer-reviewed journals. By the time careful data is released, entire narratives have already rooted themselves in millions of minds. To correct them is like trying to catch smoke. And yet, beneath the noise lies something tender: fear. Fear that the sky may not be safe. Fear that those in power would not tell us if it weren't. Fear that our place in the universe is less certain than we wish. These fears are not irrational, they are human. They remind us how much we crave both safety and honesty. Astronomy itself is an antidote. The more transparent the data, the more open the networks, the less room there is for secrecy. The International Astronomical Union publishes orbits freely. Observatories announce discoveries in real time. Amateurs with modest telescopes confirm what professionals report. It is a science built on openness. And yet, because it deals with objects capable of ending civilizations, it is also inevitably shadowed by suspicion. Imagine lying in bed, scrolling through headlines. One story speaks of 3I divided by Atlas's strange chemistry. Another, of NASA covering up alien craft. Which draws the eye more? Which stirs the heart faster? In this way, the conspiracy is not about facts, but about feelings. It is the emotional echo of awe and dread, channeled into narrative. But perhaps we can be gentle with that instinct. After all, the sky is mysterious. We are small. To make stories is our way of reaching for control. And even when the stories are untrue, they point toward a deeper truth, that we are longing to belong in the cosmos, to know that what happens above is not random, but connected to us. So as September's surge fades in memory, and 3I divided by Atlas slips behind the sun, let us hold both stories. The scientific one, cautious and careful, grounded in data, and the human one, full of wonder, suspicion, and imagination. Both are part of who we are, creatures who measure with telescopes, and creatures who whisper under the stars. And maybe, just maybe, the real conspiracy is not hidden data, but hidden awe, the fact that we walk beneath a sky so rich in marvels that we hardly look up anymore. The comets come, the asteroids pass, and most people never even notice. To reawaken wonder may be the truest revelation of all. So close your eyes tonight and let both voices drift through you. The scientists calm. We are learning, we are watching, we are prepared. The dreamers question, what if there is more? Between them lies the balance of being human, half rational, half poetic, always searching the heavens for meaning. There is something profoundly humbling in realizing that the visitor glowing faintly in our telescopes may be older than the Earth itself. 3. I, divided by Atlas, catalogued by surveys, dissected by spectra, is not just another comet, it is a messenger. A wanderer born billions of years ago, when the galaxy was younger, when the sun had not yet drawn its first breath. Astronomers, tracing its path backward, suggest it may come from the thick disk of the Milky Way, a population of stars that formed 7 to 12 billion years ago. If so, then this object has drifted through interstellar space since before Earth condensed, before dinosaurs, before oceans, before even the idea of life here. Its biography is longer than our world's history. To look at it is to peer into time itself. Picture the moment of its birth. Around a star we will never know, dust and gas spiraled in a young planetary system. Some particles clumped into planets, some into moons, some into belts of debris, and some like 3I divided by Atlas were ejected, slingshotted by the gravity of giants, thrown out into the great dark. Exiled, it began its odyssey, carrying with it the chemistry of its origin. For billions of years it wandered the silence, untouched, preserved at temperatures barely above absolute zero. In that endless journey, it brushed past other stars. Models suggest that in just the last 10 million years, it passed within 3 light-years of several. Each encounter bent its path slightly, subtle nudges adding up across eons. About 4 million years ago, it came within a light-year of a red dwarf in Cassiopeia, changing its trajectory once more. Slowly, inevitably, those deflections steered it toward us. Think of that, a journey across billions of years, shaped by chance and gravity, ending here now at the precise moment humanity possesses the instruments to notice it. A few centuries earlier, it would have passed unseen, just another faint blur. A few centuries later, perhaps lost in noise. And yet it arrives at the perfect window, timed as though the cosmos itself wanted us to read its story. Coincidence? Yes, but one that feels almost like choreography. What does the story say? Its chemistry whispers of ancient conditions. The dominance of carbon dioxide suggests a birth in colder regions than our comets know. The nickel-to-iron imbalance hints at stellar environments different from our sun's. Each molecule is a letter, each ratio a phrase. Together, they form a sentence written in the language of formation, a language that tells us there are worlds out there built differently, stars that cook their debris in other ways, environments that produce substances rare to us but common to them. The interstellar medium through which 3I divided by Atlas traveled was not empty. Cosmic rays, streams of high-energy particles, bombarded it constantly. Over billions of years, they altered its surface, etching new molecules, shifting ratios, sculpting it into something at once ancient and renewed. Each atom of its crust is a record of time radiation damage layered like rings in a tree, bearing witness to supernovae and stellar winds it silently endured. Imagine the loneliness of such a voyage. No sunlight, no warmth, only the cold embrace of interstellar space. And yet, in that silence, preservation. The volatiles it carries, the frozen gases, the locked ices, are relics untouched by heat for longer than Earth has existed. Now, as it approaches our sun, those ices awaken. They sublimate, they roar into space, they paint tales of green light and strange chemistry. After billions of years asleep, 3I divided by Atlas is alive again, if only for a brief season. There is something poetic in this timing. A messenger from before our planet, arriving just as we learn to listen. just as our telescopes become sensitive enough to decode its whispers, just as our species begins to see itself not as isolated, but as part of a galactic community of matter and motion. In this sense, 3I divided by Atlas is not only an object, it is a reminder that we are latecomers to a much older story, that our planet is a young chapter in a book already half written, that we share a galaxy not only with stars and worlds, but with wanderers carrying messages from one epoch to another. And perhaps this explains why we feel awe when we look at it, not because it is large, it is only a few kilometers at most, not because it threatens us, it does not, but because it connects us to something beyond the span of human time. It is a thread woven between the present moment and the deep past of the galaxy. The myths of many cultures speak of messengers from the sky. The Dogon of Mali tell of starborn knowledge. The Greeks imagined Hermes, wing-footed, carrying words between worlds. The Norse saw comets as spears hurled by the gods. To us, 3I divided by Atlas is no god, no omen, but it is still a messenger, though its words are written in chemistry rather than speech. And to translate them is to learn not only about distant worlds, but about ourselves, our ability to see, to question, to listen. So as December nears and 3I divided by Atlas prepares to emerge from the sun's glare, think of it not as an intruder, but as a teacher. Think of its billion-year journey as a slow, silent letter delivered across space and time. Think of its chemistry as handwriting older than the Earth, and think of yourself as one of the first humans ever to read such a letter, to glimpse the story of a world long gone, preserved in ice and dust, arriving just in time to meet us. In that recognition lies wonder, humility, and perhaps a quiet sense of belonging. For if such messengers travel everywhere, if every star system sends its fragments into the galaxy, then we are part of a shared dialogue, a cosmic exchange of matter and memory. And tonight, as you drift into sleep, you may find comfort in knowing that Earth itself also sends its own debris outward. Somewhere, someday, another world may study fragments of us, wondering about the star system that cast them out. The galaxy is a conversation, and 3I divided by Atlas is but one voice within it. When we look at 3I divided by Atlas, we are not only gazing across space, we are gazing across time. Its orbit and chemistry suggest it comes from the galactic thick disk, a population of stars far older than the Sunday. To understand what this means, we must step back, not millions of years, not even billions, but over 7 to 12 billion years into the past, when the Milky Way itself was still young. In those early epochs, the galaxy was a different place. Star formation blazed at a higher rate. Supernovae scattered heavy elements into space more violently. The thick disk was populated with stars that burned fast and bright, leaving behind debris rich in some materials, poor in others. Planets formed there too, though in conditions unlike those of our own solar system. Their comets and asteroids were seeded by a chemistry shaped not by balance, but by turbulence. It was in such an environment that 3I divided by Atlas was born, around a star we cannot name. Dust condensed, ices froze, metals mingled, but the ratios were different. More carbon dioxide, less water, nickel abundant, iron scarce. These quirks are not random. They are the fingerprints of an ancient nursery. Imagine standing at the edge of that star's newborn system, gas giants migrating, icy debris flung outward, comets condensing far from warmth. In that chaos, one object, our 3I, divided by Atlas, was cast adrift. To be ejected is to be exiled. Yet exile gave it preservation. No star's heat to melt its ices, no planetary collisions to shatter it, only the slow, endless drift through interstellar night. Over billions of years, it became a fossil, carrying within it a record of a galaxy before our sun was even born, a time when Earth's atoms still rested in other stars, waiting for their own release. The implications are staggering. If 3I divided by Atlas truly hails from the thick disk, then it is older than the solar system, older than the Earth, perhaps older than life itself. Its chemistry is a snapshot of galactic youth, a time when heavy elements were scarce, when stars forged oxygen, carbon, and metals in furious bursts, when the galaxy's arms were still coalescing. It is not just a comet. It is a relic of the Milky Way's adolescence. This thought changes how we see it. No longer just an interstellar visitor, it becomes a time capsule. Each molecule frozen in its crust is a letter written billions of years ago. Each ratio of nickel to iron, each dominance of carbon dioxide over water, is a clue to environments we will never witness directly. By studying it, we are not only peering into another star system, we are peering into another era. Consider how rare this island fossils on Earth tell us about ancient oceans or forests. But fossils like 3I divided by Atlas tell us about ancient galaxies. They are fragments of worlds that no longer exist, messages from civilizations of stars that burned and died before humanity's story began. And unlike light, which fades and shifts as it travels, these messengers arrive intact, carrying chemistry unchanged for billions of years. Its biography is not without scars, for across that vast journey, cosmic rays bombarded it. High-energy particles tore apart molecules, reassembling them into exotic species. Nickel survived better than iron, leaving the imbalance we observe today. Some ices eroded, others were buried beneath layers of redeposited frost. Each impact, each burst of radiation, each subtle heating during a brush with a distant star left its mark. Yet, through it all, the object endured. The fact that we see it now means it survived every trial of interstellar travel. And now, by sheer chance or fate, it has arrived here. In our telescopes, its coma blooms, its tail stretches, its chemistry whispers. It is as though, after billions of years, it is speaking again for the first time. Not in words, but in ratios, in emissions, in data translated into human understanding. And what it says is both simple and profound. The galaxy is diverse. Worlds are built differently. The recipes of matter vary. There is no single template for planetary birth. For us, this realization expands possibility. If comets elsewhere are built on different foundations, then planets, too, may form with different chemistries. Atmospheres could be strange, oceans unfamiliar, the building blocks of life altered. 3I divided by Atlas does not prove life exists elsewhere, but it proves diversity does. And diversity is the soil from which life often grows. The thick disk origin also invites a more poetic reflection. If this object is older than the Sun, then it has watched our galaxy transform. It drifted when the first stars of the thin disk were forming, when the spiral arms thickened, when clusters were born and dissolved. It passed supernovae, brushed nebulae, wandered through silence. And now, it meets a civilization just beginning to understand its place. We, young and fragile, gaze at it with awe. It, old and silent, offers us a fragment of memory. In myth, messengers from before time often carried wisdom. The Greeks spoke of the Titan Prometheus, who gave fire to humanity. In Hindu cosmology, beings older than creation preserve knowledge across cycles of destruction and rebirth. In the Americas, the Hopi tell of ancient stones that record the world's beginnings. Perhaps 3I divided by Atlas is one of these archetypal messengers, an ancient stone carrying knowledge not in carvings, but in chemistry. Its wisdom is not moral, but material, a story of galactic youth, preserved in ice. As December approaches, and it re-emerges from behind the sun, telescopes will seek to decode its message fully. But even before the data arrives, its very presence has already spoken. It tells us that the cosmos is not only vast, but ancient, that we are newcomers in a galaxy where fragments older than our world still drift, that our story is woven into a much longer narrative of stars, dust, and time. Tonight, as you close your eyes, imagine that. Imagine a stone older than Earth itself, glowing softly as it passes through our sky. Imagine its billions of years of silence, now broken by human instruments. Imagine yourself as part of the first generation ever to hear its message. In that thought lies both humility and wonder, for we are not only inhabitants of a planet, but citizens of a galaxy filled with ancient voices. 3. I, divided by Atlas, is one of them, and it whispers, "Before you were, I already was." Every comet must face its trial by fire. For billions of years, 3I divided by Atlas wandered in darkness, preserved at near absolute zero. But now, in 2025, it approached the moment that would decide its fate, perihelion, the closest sweep past the Sunday. The distance would be just 0.44 astronomical units inside the orbit of Mercury. For an object of ice and dust, hardened by interstellar exile, but never tested by intense heat, this was a crucible. Would it survive intact, or fracture into shards like so many comets before it? The sun is both giver and destroyer. Its warmth awakens ices, paints tails, makes comets alive. But it also stresses them, heats them unevenly, cracks their surfaces, and drives jets that tear them apart. To pass too near is to risk dissolution. Astronomers call this the sun grazer's dilemma. Some emerge brighter and more spectacular. Others vanish, disintegrated into fading clouds of dust. Which path would 3I divided by Atlas follow? In late October, as it drew near, telescopes struggled to keep it in view. The glare of the sun swallowed it, like a curtain falling just as the performers stepped into their most dramatic scene. For weeks, we could not watch directly. Instruments turned instead to models, predictions, educated guesses. Would the nucleus, perhaps 5 kilometers across, hold together? Would the strange chemistry so rich in carbon dioxide, so poor in water, grant it resilience or fragility? To imagine the tension, think of a fragile sculpture of glass, carried intact for ages, placed suddenly into a furnace. Heat spreads unevenly. Stress fractures form. Inside the nucleus, trapped gases expand, searching for escape. A fissure deepens, a crust buckles, and in an instant, the sculpture shatters. Many comets suffer this fate. Fragmentation is not an exception but a rule. And yet, 3I divided by Atlas was different. It had already survived billions of years in interstellar space, battered by radiation, nudged by stars, scarred by dust. Perhaps this resilience hinted at hidden strength. Perhaps its chemistry, odd as it was, gave it unexpected stability. Or perhaps survival was never guaranteed, only borrowed time. If it fragmented, the spectacle would be magnificent. Multiple pieces would emerge from the sun's glare, each with its own tail, spreading like a fan across the dawn sky. To the naked eye, it might resemble a celestial flower blooming suddenly, petals of light unfurling against the black. Astronomers would scramble to observe, while ordinary people might simply look up and wonder, as countless ancestors once did, whether the sky was delivering a sign. If it survived intact, the story would be quieter, but no less profound. It would re-emerge in December, glowing steadily, offering months of study. Spectrographs would probe deeper into its chemistry. Telescopes would map its tails and outbursts. Instead of a fleeting spectacle, it would become a companion, a messenger staying long enough for us to truly listen. Both possibilities carried meaning. Fragmentation would show fragility, the impermanence of even billion-year travelers. Survival would show endurance, the ability of fragile things to withstand fire. Either way, the comet was teaching us. Astronomers compared its situation to past examples. Comet Ison, in 2013, hailed as a comet of the century, disintegrated completely at perihelion, leaving only wisps. Comet Lovejoy, in 2011, a sungrazer, shocked everyone by surviving, emerging brighter and more spectacular than before. 3. I, divided by. Atlas stood between these two fates, a coin balanced on edge. For those who follow comets, the suspense was exquisite. To study such an object was not just about data, it was about patience, about waiting through the glare, waiting through uncertainty, waiting for December dawns to reveal the verdict. It was like watching a friend step into danger, hoping, yet unable to intervene. And in that waiting lay a larger truth. We, too, live in fragility. Our planet, though massive to us, is fragile against the universe. Our civilizations, though proud, are fragile against time. Yet, like the comet, we endure. We face fire, we stumble, we adapt, we survive. Perhaps that is why we care so much. Whether 3I, divided by Atlas, survives perihelion, we see in it a mirror of ourselves, a fragile traveler tested by forces larger than it can control. Close your eyes now and picture it. The sun blazing in space, radiant and merciless. And there, a speck of ice and rock, ancient beyond imagination, threading its path. Around it, gases hiss into space, tails stretch, jets sputter, fractures spread. And yet it continues. One more heartbeat, one more kilometer, one more moment in its billion-year odyssey. Whether it emerged whole or shattered, it had already achieved something remarkable. It had reached us. It had delivered its message. It had shown us that the galaxy sends us gifts, even fragile ones, and that fragility does not mean insignificance. So, as December neared and the world turned its instruments to the dawn sky, humanity waited. Would 3I, divided by Atlas, shine again, whole and steady? Or would it appear broken, a family of fragments scattering across the heavens? Whichever it chose, the story would continue. For in its survival or its demise, it would leave us richer in knowledge, deeper in perspective, more awake to the mystery of the skies. By early December 2025, anticipation hung over observatories like a hushed breath before dawn. For weeks, 3I divided by Atlas had vanished into the brilliance of the sun, its fate uncertain. Astronomers across the world waited for Earth's orbital motion to bring it into view again, this time in the pre-dawn sky. Would it return intact, glowing with the same eerie chemistry that had captivated telescopes in September? Or would the sky reveal only a cloud of fragments, the remains of a traveler that had not survived its fiery passage? The first sightings came faintly. Amateur astronomers in the southern hemisphere, rising before the sun, pointed their instruments toward the calculated coordinates. There, against the paling sky, a smudge appeared. Not a star, not a planet, but a faint streak with a growing tail. Excitement spread quickly. 3I divided by Atlas had survived. News traveled fast through the networks of professional and amateur observers. The comet's coma seemed altered, brighter and more diffuse than before perihelion. Its tail stretched longer, braided with multiple strands, suggesting that deep layers of volatile material had been exposed. In some ways, it looked healthier than ever, like a traveler who had passed through fire and emerged transformed. For those who had feared fragmentation, this was a relief. The nucleus, though battered, was still coherent. Spectroscopy revealed that the chemistry had shifted subtly. Alongside the dominant carbon dioxide, new signals appeared: traces of water vapor, carbon monoxide, and other volatiles previously hidden beneath the crust. It was as if perihelion had peeled back layers of history, allowing us to glimpse not only the surface, but the deeper composition of this interstellar relic. Picture it in the dawn sky, a pale streak rising low, just ahead of the Sunday. Most people slept on, unaware of the visitor above their horizon. But those who looked up saw something ancient and foreign, carried across billions of years, now unveiled in morning silence. The stars faded, the sky blued, and still the comet lingered, whispering its story before the sun washed it away. In major observatories, instruments were trained with precision. The James Webb Space Telescope turned its gaze once more, dissecting infrared light to read the comet's chemistry. The Very Large Telescope in Chile sharpened its spectrographs, hunting for nickel lines and water ratios. Even radar arrays probed what they could, though distance limited detail. Each photon of light carried information, a clue about the comet's past. Together, they built a portrait richer than anything we had seen before. But the story was not only scientific. For many, it was also emotional. Humanity had waited through uncertainty, and now, like the return of a lost traveler, three, eye divided by Atlas, reappeared. It was still here, still glowing, still reminding us of our connection to the wider galaxy. Its survival felt like a small reassurance in a world so often marked by fragility. There was poetry in the timing. As the northern hemisphere entered winter and nights grew long, this messenger from before Earth returned to our sky. Fires burned in hearths, celebrations of light-filled cities, and above it all, in the cold hours before sunrise, an interstellar visitor traced its arc. Few noticed, fewer still understood. Yet those who did felt something shift inside them, a recognition that the cosmos had offered us a rare gift, time, with a relic older than the Sunday. Still, survival did not erase mystery. The comet's episodic brightening continued, flaring unpredictably. Its rotation remained hard to measure, as though it were tumbling irregularly. Its chemistry still defied easy explanation, whispering of environments far colder and stranger than any we knew. It was a survivor, yes, but also a puzzle, and puzzles are the true treasures of science. Some compared it to a book missing its cover and half its pages, yet still filled with enough words to change how we see the world. 3. I, divided by Atlas, was such a book. Each observation revealed new fragments of its narrative formation in a distant star system, exile into interstellar space, billions of years of silence, and now a dramatic passage by our Sunday. We will never read the whole story, but the parts we hold are enough to alter perspective. And so December became a month of quiet triumph. Papers were drafted, observers compared notes. Teams around the world collaborated across time zones, languages, and cultures, united by the glow of a single, ancient wanderer. For a moment, humanity's divisions faded, replaced by shared curiosity. Close your eyes now, and picture it once more. A faint smear in the dawn, older than Earth, glowing not for itself, but for us, who finally had the eyes to see. Imagine the patience of that journey, the silence of interstellar space, the endurance across eons. And then, imagine the gift of its return, a fragile survivor that had passed through fire only to shine again. In this, there is a lesson. Survival is not about avoiding trial, but about enduring it. Even fragile things can withstand fire, if only for a while. And sometimes, in that survival, they reveal more than they ever did before. For much of human history, the galaxy seemed like a painting on the ceiling of night, stars fixed in their places, constellations eternal. It was a comfort, this illusion of stillness. But 3I divided by Atlas reminded us that the Milky Way is not static. It is alive, restless, exchanging matter across its vast spiral arms. Astronomers now believe that every planetary system, during its chaotic youth, throws debris outward. Some fragments fall inward toward their stars. Others remain bound in belts. But countless more are exiled, flung onto hyperbolic paths that carry them into interstellar space. Multiply this by hundreds of billions of stars, and the galaxy becomes not a silent void, but a busy highway of wanderers. 3I divided by Atlas is not unique. It is part of a diaspora of fragments, messengers traveling between suns. Think of it as a cosmic ecosystem. Just as seeds drift on winds between forests, so too do comets and asteroids drift between stars. Some carry ices, some metals, some organics. Each is a sample of its home environment, a portable record of chemistry and history. The galaxy is constantly seeding itself with these fragments, scattering memory across time and space. To catch one, as we have now, is to hold a piece of another world's past in our hands. This realization reframes everything. Earth is not isolated. Our solar system is not an island. It is a rest stop along a galactic exchange, a participant in a dialogue written in dust and stone. Every interstellar object that enters our sky is both visitor and teacher, reminding us that the Milky Way is an active network, not a backdrop. In this light, the September surge feels less like coincidence and more like revelation. Dozens of near-Earth asteroids, a brightening comet, an interstellar wanderer. Perhaps these events were unconnected in mechanics, yet connected in meaning. They showed us the true complexity of our neighborhood, the way our solar system is threaded into the galaxy's larger patterns. For every rock that sails close, there are countless others we never see. Shadows passing silently beyond the reach of our instruments. Imagine drifting among the stars as 3I divided by Atlas has. For billions of years, the galaxy's spiral arms turned overhead. Stars were born, flared, died. Clouds condensed, scattered, coalesced again. The comet saw them all, not as a witness with eyes, but as a traveler absorbing their energies. Cosmic rays etched its surface, collisions nudged its course, gravity bent its path. Its journey was not solitary but interactive. The galaxy touched it, reshaped it, carried it along. And now it touches us. The chemistry of 3I, divided by Atlas, is more than a curiosity. It is evidence of galactic variation. Stars in the thick disk, where it likely formed, had different metallicities than our Sunday planets built there, were not the same as ours. Comets condensed under colder, harsher conditions. By studying this single object, we glimpse how diverse planetary systems can be. Some worlds may be rich in carbon dioxide. Others may lack water altogether. Some may carry metals in strange proportions. The galaxy is not uniform. It is a quilt of environments, stitched by time and gravity. This diversity carries implications beyond science. If planetary systems form differently, then life itself, if it arises, may take forms stranger than we can imagine. Perhaps water is not always the essential solvent. Perhaps carbon finds companions other than hydrogen and oxygen. Perhaps elsewhere, entirely different chemistries give rise to patterns we would still recognize as living. To study 3I divided by Atlas is to stretch our imagination outward, to realize that life's possibilities are as wide as the galaxy itself. There is humility in this, for Earth is not the center of creation. Our chemistry is not universal. We are one expression among many. And yet, there is also comfort. The very fact that fragments travel between stars suggests connection. The galaxy is not made of sealed compartments, but of open systems. Materials flow, Information flows. In some deep way, we are already sharing in the collective memory of the Milky Way. Poets once imagined messages carried by the stars. Perhaps they were not wrong. These messengers are not letters written in ink, but in ratios of gas and dust. To read them is to learn that our galaxy is alive, alive with exchange, alive with movement, alive with the circulation of matter across unimaginable distances. Tonight, when you gaze at the sky, remember that. The stars you see are not silent points. They are engines of creation, scattering fragments, seeding the void with wanderers like 3I divided by Atlas. The galaxy breathes, and its breath is comets. The galaxy speaks, and its language is chemistry. The galaxy moves, and its footsteps are the trajectories of countless exiles threading through the dark. And we, fragile and curious, have only just begun to listen. So as 3I divided by Atlas continues its passage, remember that it is not alone. There will be others. More interstellar visitors will arrive, some unnoticed, some spectacular. Each will carry a piece of the galaxy's story. Each will remind us that we live not in a quiet corner, but in the midst of a cosmic symphony. For the Milky Way is alive. And to know this is to wake from the illusion of isolation, to feel ourselves as part of something vast, dynamic, and enduring. Encounters like the September surge of 2025 do more than stir science. They stir imagination. For when we watch asteroids thread past Earth, comets flare, and an interstellar wanderer whisper secrets, we cannot help but wonder, what comes next? The future branches before us like a tree with many paths, some bright, some shadowed, and in the stillness of night, drifting towards sleep, we can follow those paths in thought. One branch leads toward mastery. In this future, the lessons of FA22, Chelyabinsk, and 3I divided by Atlas are taken seriously. We invest in telescopes like Rubin and Neo-Surveyor, in missions like DART and Hera. Within decades, our planetary defense becomes routine, like weather forecasting. Potentially hazardous asteroids are detected years in advance, and with gentle nudges, their paths are altered. Humanity learns to shepherd the sky, not in panic, but in quiet confidence. Impacts, once fate, become preventable accidents avoided. The sky, once a threat, becomes a managed neighbor. Another branch is scientific wonder. Here, interstellar archaeology blossoms into a discipline. 3I divided by Atlas is not the last visitor we study, but the first of many. With better surveys, we discover a dozen more in the coming years. Each carries a unique chemistry, a unique origin. Some formed around low-mass stars with cold disks, others near giants with exotic metals. By the 2030 seconds, we begin mapping planetary formation across the galaxy, not through distant starlight, but through physical samples carried to us. The galaxy, once abstraction, becomes tangible. Its diversity is written in ice, dust, and ratios we can measure. And perhaps, in that exploration, we glimpse something deeper, a signature, not of natural chemistry, but of processing, order, perhaps even intention, not proof of life, but the whisper of possibility. Even the hint would reshape how we see ourselves. For if we are not alone, then the galaxy is not only alive with matter, but alive with mind. But not all futures are gentle. There are branches shadowed with vulnerability. In these, a city-killer asteroid slips past our watch, discovered only months before impact. Panic spreads. Nations scramble. Deflection is attempted, perhaps with nuclear force, perhaps with desperate improvisation. The result is uncertain. Even if successful, the scars on trust and cooperation may remain. Humanity learns the lesson too late. Vigilance cannot be optional. There are darker futures still, A kilometer-wide object, rare but not impossible, approaches with too little warning. Deflection is beyond us. The impact comes, reshaping climate, dimming skies, threatening global civilization. Survival continues, but at cost. In such a future, the stories we tell afterward would carry the weight of myth, the flood renewed, the fire rekindled, the reminder that the sky does not bend to human will. And yet, even these paths hold meaning. For catastrophe too is a teacher. If such an event comes, it will not end humanity but transform it. Our species has endured ice ages, plagues, wars, and extinctions. We are fragile, but we are resilient. Perhaps one day, we will tell stories of the great impact, the way we now tell stories of the deluge, not with despair, but with memory. Between mastery and catastrophe lie countless middle ways, futures where we grow steadily, better at watching the skies, but not perfect. Futures where we prevent some threats, but miss others. Futures where interstellar archaeology flourishes alongside planetary defense, weaving protection and curiosity into the same fabric. In every branch, one truth remains. The galaxy is active, and we are part of it. Whether we shepherd stones, study comets, or endure impacts, we are no longer passive. We are participants in a drama larger than ourselves. The very act of watching the skies, of preparing, of imagining, draws us deeper into that role. And here lies the gentlest future of all. A future where awareness itself is transformation. Where even without grand technology or perfect defense, we find meaning in recognizing our place. Where we look up not with fear, but with belonging. The sky is not against us. It is simply alive, and we are learning to listen. Close your eyes and follow that future. Picture telescopes scanning, spacecraft nudging, scientists collaborating across continents. Picture children in classrooms, learning not only of dinosaurs' extinction, but of the comet that whispered from before Earth was born. Picture humanity awake to the cosmos, not as a threat, not as an afterthought, but as home. For in truth, all futures are possible. Mastery, wonder, vulnerability, catastrophe. Which path we walk will depend not on the heavens, but on us, on our choices, our cooperation, our willingness to see far and think long. The stones will keep coming. The wanderers will keep arriving. The galaxy will keep sending its messages. The question is, will we be ready to read them? And tonight, as you drift towards sleep, let that question be gentle, for to even ask it is progress. To imagine futures is to prepare for them. To tell these stories is to make space for their answers. The sky is alive. The galaxy is alive. And so are we, awake beneath their light, dreaming of the paths ahead. To look at the September skies of 2025 is to realize how much our perspective has shifted. Once, humanity saw the heavens as fixed and eternal stars wheeling predictably, planets wandering slowly, comets arriving rarely as omens. But the discoveries of this season told a different story. The heavens are not still. They are alive with motion, exchange, and surprise. And to recognize this is to change how we see ourselves. The close passage of FA22, the brightening of comet Swan, the steady approach of Apophis, and above all, the arrival of 3I divided by Atlas together, these events tore away the illusion of cosmic isolation. Our solar system is not a sealed world. It is a crossroads. Stones arrive from afar, brush past, sometimes linger, sometimes leave. And every one of them reminds us that we are connected to something far larger than our planet. This recognition is humbling, for it shows us how fragile Earth Island, a single object, a few 100 meters across, could devastate a region. A larger one could alter climate for years. A giant could reshape life entirely. We live not in perfect safety, but in a moving stream of matter, vulnerable, yet enduring. To know this is to cultivate humility, a recognition that our world is precious precisely because it is precarious. But this recognition is also empowering, because, unlike the dinosaurs, we can see, we can prepare, we can act. The very act of building telescopes, of sharing data, of practicing deflection, is proof that we are becoming participants rather than victims. We are no longer passive beneath the sky. We are active, learning, readying ourselves. Awareness itself is strength. And more than strength, it is perspective. For when we study interstellar visitors like 3I divided by Atlas, we learn that our solar system is just one among billions, and that matter flows between them. The water we drink, the carbon in our bodies, the iron in our blood, these elements were forged in ancient stars, scattered across the galaxy, gathered again in Earth. To realize this is to feel kinship with the cosmos. We are not separate from it. We are expressions of it. This perspective echoes in our myths and memories. Cultures around the world have told stories of stars as ancestors, of comets as messengers, of floods and fires descending from the heavens. Today, with science, we translate those stories into data, but the awe remains the same. When we see 3I divided by Atlas, glowing green with alien chemistry, we are doing what our ancestors did, looking upward, searching for meaning, finding ourselves reflected in the sky. Perhaps the most profound shift is that of scale, for daily life shrinks us into small circles, cities, nations, even our planet. But the cosmos stretches that circle outward. It reminds us that borders are illusions, that our atmosphere is thin, that our world is one among countless others. Problems that divide us seem smaller against this backdrop. The perspective is not escapist but grounding. We are one species, on one fragile world, in one vast galaxy. This awareness carries responsibility, for if Earth is rare, and it may be then to squander, it would be unforgivable. To pollute its oceans, to burn its skies, to fracture its societies, while knowing how precarious life is, would be folly. The cosmic perspective turns stewardship from a choice into a necessity. To care for Earth is not only ethical, it is survival. And yet, within that responsibility lies comfort. For we are not alone in our fragility. The galaxy itself is fragile. Stars die, systems scatter, comets wander. Everything changes. Everything passes. Yet, within that passing, beauty arises. The light of stars, the glow of comets, the rhythm of planetary orbits, all are born of impermanence. So too are we. Our fragility is not weakness. It is our belonging to the greater story. Close your eyes and imagine again 3I divided by Atlas. A comet older than Earth, glowing faintly in December skies, carrying secrets of another world. It does not come to threaten us. It comes to remind us that we are part of a living galaxy, that our story is woven into larger cycles of matter and time, that every breath we take connects us to stars long gone and stars yet to be born. This is the cosmic perspective. It is not only about asteroids and defense. It is about wonder, humility, and belonging. It is about realizing that when we look up at the night sky, we are looking into our own history and our own future. The comets and stars are not separate from us. They are our kin. And perhaps, as we accept this, we will find new ways of living on Earth, ways rooted not in fear or division, but in recognition of our shared place in the cosmos. The September surge may have been brief, but its lessons are lasting. We are fragile, but not helpless. We are small, but not insignificant. We are, and always have been, cosmic citizens. So tonight, let this thought cradle you towards sleep, that the galaxy is alive, and so are we, that we are part of its story, as much as it is part of ours, that in the fragile glow of a distant comet, older than Earth itself, we are reminded of both our smallness and our significance. And that, perhaps, is the greatest gift of all. As winter deepened across the northern hemisphere, the story of September 2025 settled into memory. FA-22 had passed safely. Comet Swan had fled. Apophis waited in the wings. And 3I divided by Atlas, the ancient wanderer, had survived its trial by fire, re-emerging into dawn skies with a chemistry stranger than anything we had seen. What began as a series of observations became something larger, a reminder that we live not in isolation, but in a galaxy alive with exchange. Looking back, it is tempting to see choreography, a parade of asteroids, a brightening comet, an interstellar messenger, all within weeks. Was it coincidence? Or was it the galaxy reminding us that we are part of its dance? Science leans toward chance, but chance, when framed by wonder, becomes meaning, and perhaps that is enough. For what truly matters is not whether the events were connected, but what they revealed, that we are beginning to see clearly. The Rubin Observatory sweeping the sky every few nights. Space telescopes preparing to watch from beyond Earth's atmosphere. Networks sharing data across nations. Humanity, fragile though it is, has built eyes wide enough to notice the wanderers. That alone is a milestone. And in those wanderers, we glimpse our own reflection. FA-22 reminded us of our vulnerability, the reality that impacts are not myths but inevitabilities. Chelyabinsk echoed that lesson, showing how even small stones can wound when they arrive unannounced. Comet Swan displayed the beauty of fragility, a dirty snowball shedding its body into a luminous tail. Apophis, looming in 2029, promises a spectacle that will test both our science and our awe. And 3I divided by Atlas, older than Earth, stranger than expected, whispered of worlds beyond, of chemistry's alien, of a galaxy filled with diversity. Together, they offered a cosmic education, a lesson in humility, resilience, wonder, and responsibility, a reminder that we are citizens not only of Earth, but of a wider neighborhood where matter flows freely, where stars exchange debris, where the galaxy itself is restless. This perspective reshapes how we think of ourselves. No longer can we imagine Earth as an island untouched. No longer can we see the sky as distant decoration. Instead, we see connection. The carbon in our cells, the water in our veins, the iron in our blood, all forged in stars, all once fragments, like 3I divided by Atlas, all exchanged across the galaxy. We are not visitors here. We are products of the same processes that flung comets into space. We belong, and with belonging comes duty, to care for our world, to protect it from stones we can now predict, to share knowledge across borders, for the sky knows none, to prepare not in panic, but in wisdom. Planetary defense is not merely about survival. It is about stewardship of Earth, of knowledge, of the fragile conditions that allow life. But beyond duty lies wonder. For the more we see, the more we realize how rich the cosmos island. Each interstellar visitor is not just a threat or a puzzle. It is a gift, a fragment of another time, another place, delivered across unimaginable distances into our care. To study it is to expand our imagination of what is possible. To hold its chemistry in our instruments is to touch the ancient galaxy itself. And so, as the December mornings of 2025 faded into January and 3I divided by Atlas grew fainter, humanity was left with more than data. We were left with perspective. That our solar system is open, not closed. That our galaxy is alive, not static, that our story is woven into larger ones, stretching back before Earth was born. Close your eyes and picture it. A comet older than our world, glowing faintly in the dawn, its tail streaming across the sky. Around you, the Earth turns, oceans shimmer, cities sleep. Above, stars burn, planets wander, asteroids drift. All of it connected, all of it alive. And you, lying beneath it, are part of that vastness, not separate, not small, but belonging. This is the cosmic perspective, to be both humbled and comforted, to feel the fragility of Earth, yet also its significance, to recognize that in a galaxy of billions of stars, we are not alone in matter or history, to see ourselves as citizens of something larger. The September surge was only the beginning. More visitors will come, more comets will flare, more asteroids will pass. And with each, our awareness will deepen. The true adventure is not only in protecting ourselves or cataloguing the sky, but in learning to live with this awareness, that we are part of a galaxy alive with exchange, with memory, with wonder. So tonight, as you drift towards sleep, let that awareness hold you. You are not alone. Earth is not alone. We are all part of a living galaxy, sharing its breath, its dust, its fragments, its stories. The stars above are not distant, they are kin. And every comet, every asteroid, every interstellar visitor is a reminder that we are connected. We are citizens of the galaxy, and the adventure of understanding has only just begun.